Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Chris Jackson, and we're talking today about some of the really damaging effects you can have when your organization is split like a razor between, seemingly split by a razor between those who design and those who manufacture.
Well, it's the old euphemism was to throw it over the wall, because they're luckily just in the next room and you just throw it over the wall to them. That doesn't exist much anymore. There are examples where people have design and manufacturing in the same building or in the same city or even same country. Yet over the last 20, 30 years, I've rarely run into a case where that manufacturing was local enough that you could just use the same language, in many other barriers. But the concept here comes from a question that it was a discussion. It wasn't really a question. I was talking to somebody, and it was a manufacturing engineer was like, how can I help the design understand that we typically can only make their design worse? We add variability, and they're giving us these impossible specs and impossible assembly things and stuff like that. And we keep pushing back, and we're trying to do this design for manufacturing thing, and we're just stalling because the designers just think they know best and they ignore any of our overtures. And so we talked about that, and I thought that might be a good conversation, because if it really is two different entities and each with their own priorities and goals and everything else, the product's probably doomed.
Right. And it's the message here too is that, look, you want your competitors to be having these issues and not your organization. If your competitors have designers who just think they know best and routinely churning out infeasible designs when it comes to manufacturing high quality, and you're going to really start having some good outcomes when it comes to profit margins if you can be the one that's not doing that stuff.
Yeah. Well, part of the discussion was, one of the pushbacks he was getting was, well, you only tell us what you can't do. Kind of a problem is the design team is trying to solve lots of problems, and the manufacturing folks are coming up saying, our equipment can't meet that tolerance. And, the design teams will get a better equipment or, improve it or whatever. It was kind of the we versus them kind of conversation. And I thought, well, what would be some practical ways for the manufacturing team to say, here's how I can actually help the design. Here's how we can, here's the information, here's the data, here's the constraints and so on, without it becoming I say, you say kind of stuff.
I mean, it's all, you and I have a bit of a different perspective on some of these things. You tend to, no matter what I would argue, think there's always something you can do. And I'm a little bit more pessimistic and say, look, unless you start to have these conversations before you design stuff, it's always a real challenge. It really always is. Someone's telling us, well, you're always giving us problems. You're the one who gives us problems. And that's a sort of refrain that a lot of reliability engineers hear over the years as well. You're here to tell us what's going to fail. It's all you're telling us problems, telling us what the problem is. You're telling us what you can't do. And it's a defense mechanism, to be honest, by those people who haven't actually taken the time to think about this stuff themselves when they rush to make their wonderful, amazing design. But again, one thing I do, one approach I often try to use is say, hey, look, and it's like I mentioned, we want our competitors to be the ones where the designs are not compatible with our machines or machines we can purchase, our manufacturing machines. We want it to be other organizations, other designers, other producers. We want to be the ones where the design is easily manufacturable by the stuff we have or the stuff we can get, which means it's going to be high quality, which means it's going to last longer, which means we are going to make a lot more money than our competitors who are expending the same amount of effort as we are, but getting poor quality results or defective products that fail often during warranty periods, et cetera, et cetera, et cetera.
Yeah.
And so if you have that as the reason, if you say that this is what we're trying, this is the goal, this is the thing we're trying to achieve. Now, if we say design team, bring it in team, designers come over here. If you think that you can design whatever you want, and there is a manufacturing machine out there just waiting to be purchased from Amazon or eBay to realize your vision, you need to think again. You need to think about what are the easiest ways to manufacture your thing and use your design genius to come up with designs that are easily manufacturable. Up to like manufacturers, you need to be the guys who tell designers what the art of the possible is. But that's sort of not resolving this guy's problem where you have that cultural impasse.
Yeah, that's where I find the issue is that sometimes it's siloed so strongly that the operations manager has their own goal for, reducing scrap and doing this and doing that. So they basically hammer on the inspection teams to loosen up the inspections, the more passes. They may not say it deliberately, but it is like, well, the yield is too low. You got to fix that. And well, you can't fix the design because of our internal company culture. In some organizations, then the ops manager hires essentially a whole development team that might call them sustaining engineers, and they go redesign the product once it gets handed off to manufacturing so that they can actually manufacture it. And it's like, what a waste of time.
Right.
And they build their own empire and own system to do it. Yet the motivations and the corporate KPIs and bonuses and benefits and everything else is ops does not talk to design, and design has to innovate so nobody can talk to them and blah, blah, blah. And that's the old hierarchical, I don't know where it comes from, but it's prevalent. There's no doubt about it. So that conversation is, here's what we're trying to do, is really at the CEO, senior VPs level to get the breakdown of those silos. Now, as a manufacturing engineer, I've walked into a design team guy and he was, talking about, I'm only bring problems. This is, look, it's not that I bring you a problem. Here's the reality of it. If I try to make this with our current equipment on the prototype runs we've run a couple hundred boards through, the yield rate is this. And that's 4 times what we typically do for products that get shipped out of this plant. And this impacts the gross margin of this product in a substantial way. Do you want me to tell your boss that, or do you want to tell him that? It's like, our bonus at the level we're at comes from if the company's profitable. And if they don't make their targets on profitability, we don't get a bonus. Right? And it's also not good business to leave a bunch of money in the scrap bin over here, because the design is pushing the capabilities of our equipment to the point where we have to throw away a third of it. And he goes, oh, I didn't know it would impact that. And well, how do I fix that? And I was like, here's the process capability information. Here's the specs that you're expecting us to do. Here's our machine's capability that we measured. Can we open the specs, or can we find another solution to do it? And I thought that actually helped. If I actually was armed with, here's the impact to cost, which was a real driver for this product's overall performance. And if you saved a nickel on this component that has horrible, variability, which causes this problem, if you spend a nickel more, we could save 50 cents per board and reduce scrap. And I was, oh, okay, I get that. But it wasn't just, I can't deal with that part. Don't use that part. I think part of it is in the way we present. And some of those discussions may go very senior or corporate organizational system type stuff, which needs to happen. Or it could be, what's the priority for this program, for this particular design team and their product outcomes and so on. And almost always profitability is in there somewhere. or at least a path to profitability. You got to include the startups in this. You got to do your homework. Why does this cost so much? What's the actual evidence? What's the real numbers? Luckily, the guy I was working with was really like charts and numbers and stuff like that, calculations.
Right.
I'm sure not every designer does that, or engineer does that one form or another. But one of the issues I have, and it's the same with reliability folks, is like, well, you can't do that because it'll hurt reliability. And that's not a sufficient argument.
No. You say, well, it might hurt reliability. These are the things you could try to minimize or mitigate that hurt.
Mm-hmm.
If so, it will cost you this much. And if you haven't completely eliminated that hurt, well, it's still not over because it still might be the right decision to have that less reliable thing. But because it has more functionality as a result, it's more profitable. You look at one of the easiest ways to improve warranty reliability for cars is to remove all the fancy bells and whistles, the adjustable mirrors, the
old
in-seat warmers.
mechanical seat forwarder work just fine. I don't know how many people I've run into that have a seat, that has memory. You get in the car and it remembers you because it's your
Right.
key, and it automatically adjusts the seat and the rearview mirror and everything else to your preferred settings. You don't see those much anymore because they had too many ways they didn't work.
Right. So one of the easiest ways to improve reliability is to cut functionality. No one will buy your stuff, but I mean the automated seat adjuster device, whatever we want to call that thing. That's one thing. But we have turn-by-turn navigation essentially in the dashboards or the dashes of virtually every new car there is these days. That's a complex system in its own right.
Well, there's communication systems. There's, the 911 sensor systems. Are you all right? Should we call 911 if they're still working? And they have battery backups for those and kind of stuff. I think one of my neighbors talked about they did a hard stop and their system came on with a live voice saying, "You had a sudden hard stop. Are you okay?"
Right.
Just checking. Okay, thanks. It's kind of spooky. Somebody's watching you drive.
Right.
But I agree with you. Cars these days are becoming more computer than actual mechanical drive systems. Even the engines themselves have all kinds of chips and sensors and computers on them. Carl would know more about that. I think he's kept track of the count of computers in cars. But yeah, make it simple. A simpler solution is almost always more reliable. If it provides the function that adds value to the customer, that's great. Yet I'm guilty. Years ago, I had a car and I didn't really care for the sound system that it had. It wasn't a primary thought when I bought the car, but it really was pretty crap. So I went looking for aftermarket options, and it was the way they designed the car. It was going to be very expensive to upgrade the sound system because of all kinds of design trade-offs they did, so that you couldn't really easily economically use a third-party sound system and get it installed. So I went and bought a new car with a better sound system.
Right.
And yeah, that's a way to sell more cars. That I never bought that brand again.
Right. Which means that you can't be that reliability engineer who says no to any idea that, threatens a reliability number that person has in their head.
Yeah. Part of it is and I mentioned it earlier, is do your homework, is what's important for that design team, for that organization. Oftentimes profitability and profit margin is a piece of that. Yet that's a hard one when there's such strong silos. And yet if the team has a clear concept of what they're trying to achieve, and if the warranty cost gets too high, if the customer satisfaction is the primary driver for the way the organization operates, get the numbers. How does this, if you pick the right part that we can actually manufacture with the equipment we have or with the equipment we can get in tolerance, let's do the calculation of when it's, how often is it out of tolerance? And we're not going to catch all of those. So those are going to cause problems in the field, right? Let's figure out, well, let's get a back of the envelope calculation, or better if we need to say, if we use this part, one, we'll take a hit on scrap. Two, we'll ship bad products into the tune of 1-2%, or whatever the number you can calculate out is. And here's the evidence. And if we increase by 1 or 2%, this overall project's going to spend X amount on warranty, and then we just won't have any warranty. Customer satisfaction will plummet, because here's the evidence from the last 10 products that didn't meet expectations, and they all got recalled. And it does take a bit of work. I often have mentioned on this show and into clients I work with, is one of your best friends as a reliability engineer is somebody in finance. Go find somebody that can help you run the numbers for the financial impact of decisions that are being made. They are your secret weapon.
I remember that an organization I once worked for, where they were not the secret weapon. They were weapons, but in the wrong way. Like I was sitting down because I was trying to do essentially what you're suggesting. How do we come up with ways to build the business case for doing this?
Mm-hmm.
And I just sat down with these. Because I've been bouncing from, go see these people, they'll have these numbers. And finally found the person, and she just looked at me, she says, we just don't see it as our role to give you that, to research that information. And I said, well, if it's not your role, whose is it? You're chief of finance.
Yeah, and you have all the numbers.
And I said, this is an engineering, this thing is an engineering organization. And I remember looking at it and said, well, what is your role here then? What's your point? And this was chief of finance, so I wasn't a junior person. And the meeting went south there afterwards. And I said, no, we're here to design stuff, and you're here to help us support. We're not here to help you create budgets. You're here to use those budgets,
make decisions.
Right.
Okay.
Anyway, it was bad, and that's an organization I didn't take too much longer to get out of.
Yeah, I remember that. I had one where the organization called me in because they had so many failures, and nobody in the rest of the organizations outside the manufacturing team was paying attention to it. And it was such a pandemonium that my host met me at the door and said, I'm really, really sorry. I'm double booked and triple booked. I got to go take this meeting and go to this phone call and stuff. I'll be back in about an hour. There's the coffee pot. There's the bathroom. I'll be back. One, never leave me alone in your building. Because I wandered around, and just by chance, and I was looking for him or her, was the chief financial officer. And happened that I went to the front desk and asked, where's the CFO sit? And she said, that's him, Bill, meet Fred, Bill. And he looked at me like, what are you here for? He says, well, I'm investigating why you have so many failures in the field and its impact on your margin. And he goes, oh, I got a few minutes. Let's talk. And he said, yeah, we've seen a lot of, replacements, and the operations team wants to spend a whole bunch more money and expand their thing and their operation and everything else. I didn't realize it was to make products we're going to give away for free. They just were asking for more capacity, because the long story short is they were making 3 brand new units for every one they sold, because it failed so often under the warranty. They replaced it at least twice for each one they made, and they were running out of capacity. And I said, well, why would the organization not be paying attention to warranty and all these failures? It goes, well, warranty is actually really, really small. It's like $50,000, and it was a $100 million company. And I'm like, well, that doesn't make much sense. What do you count in your warranty line in your financials? The replacement parts. It was, a handful of screws and a motor. And you got to be kidding me. You're not counting all of the field service people that are, working with customers to, install the new one. Because every time you install a product, it's like one of your people fly out there and install it for them. And then all of the whole unit gets scrapped because you can't sanitize it anymore. It's a medical device. And are just counting that, well, the motor failed, so you're only counting the motor and not the transportation, not the brand, worth, all these other things. And he started thinking about it and goes, well, the manufacturing team is asking for like 3x what they should be asking for the forecasts for sales that we do. Yeah. Okay. You didn't pick that up, did you? And at that point, he was like, maybe I should stop talking to you. I was like, who are you again? Where you come from? Because I was just standing in the lobby when he walked in. He had no idea who I was, really. It's sometimes organizations fall into patterns, and well, manufacturing always complains, and well, we just have to ignore them and get our design right. I think the issue is that in order to get the design right is, how does manufacturing actually inform the design decisions so that you get that easy to build, low scrap rate, high performance product? If you stay within those sweet spots, it likelihood of creating a consistently reliable product is pretty good. Or go like Apple does and invent whole new manufacturing systems that can get the tolerances that you envisioned or hallucinated. But they put the money there to go do that. And I think those things matter. The getting it, that communication, that syncing matters. Now, I may be tainted a little bit because when I was working at Hewlett Packard, one of the product teams I worked with when I first got there, the mechanical engineers had a mechanical process engineer in the same office with them, same cubicle. They always were working side by side because the mechanical assembly really, 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 let me repeat that, really depended on the ability to assemble it. And so they had the person designing the robots and the equipment and the assembly process right from the very start of the program, working with that mechanical engineer designing that assembly.
Right.
And that's about as close to perfect design for manufacturing team as I can think of.
Right.
Electrical guys, not so much. The manufacturing was all in Asia somewhere, and those guys said, well, we can make anything. You just tell us what to make. We might not make it well, but that's the problem.
But I was also, the thought just flashed my mind. I mean, it's all well and good saying, okay, designers, you need to speak to the manufacturers or technician, whoever it is. And in organizations where they sometimes are in the same building or in the same organization, you have one designer who will get off his backside or her backside and walk over to the facility and say, hey, I'm designing this thing. What do you think I need to look out for when I design it to make it easy for you guys to manufacture? That's one way of doing it.
Yep.
Another way of doing it is being a design engineer or designer, design something, then puts into their calendar a meeting in their conference room which invites the manufacturing people to come across and critique their amazing design. And technically both approaches are engaging the manufacturing team, but I'll tell you what, which one's going to work, which one's not. It's
which one has pizza?
Well, it's also, I mean, if you're going to try and suck information out of the brains of people who have a full-time job doing their thing, and I've seen this, it's an real life, an example, a real life scenario where they said, well, we had a conference room and it was 2:00 on a Wednesday and no one turned up. And they're saying, can you believe these guys? I don't turn up. In our conference room, 3 buildings over. Yeah, I can actually, because it's all about you. It's all about you minimizing how many steps you need to take away from your computer for your design. It's all about doing it in a setting that works for you. It's all about waiting until you've done something for them to critique it. It's all you. If you are serious about getting manufacturing stuff, manufacturing ideas or manufacturability ideas, I should say, be proactive and show those manufacturing team that you actually care. And I've seen those people who they say, oh yeah, Sarah, she's always down here trying to pick our brains about how to do this.
And she's watching the line. She's looking at our prototypes. She's,
right.
Looking at, sometimes it goes both ways. It's like, so why do you do it that way? And it becomes a brilliant breakthrough and you can get more consistency out of your process. And other times it's like, oh, okay, now I see why that doesn't work. Do we have other options? Can we use lasers instead or something? Like, well, here's the cost. Oh, okay. Let me change my design. But yeah, I get that. The people that actually invest in learning about how the products is made and what the constraints are will get a whole lot more attention. There's no doubt about it.
Yeah, it's and when you get more attention, you get better designs. The Sarah person, was actually her name. She was the one who's, you know, borderline pestering them. And they appreciated it though. They said, yeah, she's always down here pestering. They actually appreciated where she's coming from. They appreciate that she'd get off her backside and come down there and ask some questions and and they had a good relationship. And she would be designing stuff which weren't stupid. The thing is that stupid to manufacture, let's just say that from the very start. So she didn't have to fix problems.
I have this conflict of interest though when it comes to this problem. We shouldn't really solve it too much, Chris, because I don't know how many clients I've had that call me in to their building and they're actually in the same building. They're manufacturing and assembling their product, and the design team's kind of another part of the same building. And they wanted me to understand that, and it was this connector. Once you assemble it, because of the way it was assembled, there was a cable that had to be connected to some other part that was down a narrow slot between the chassis and the system. And the connector was underneath it, so you couldn't see it.
Right.
And the connector did not have a positive lock indicator of any kind. It didn't click. If you pull on it, it will always come out. So you never knew if you had it seated all the way or not. Right. And then you can imagine that the amount of dead on arrivals they had was pretty high. Right. And they told the design team, they, raised it up the flagpole. They did all this stuff and saying, we know why we have all these problems in the field when they first unbox these things. This connector comes loose. And so the design team and the senior manufacturing management team said, we'll make sure the connector is connected. We can't. Even if you seat it all the way, you can't tell if it's seated all the way. We can't see it and all this other stuff. So the plant manager, like right above was a step above the supervisors, called me up and said, can you come in and take a look at this thing? I said, why didn't you tell the design team? We tried. They don't listen to us. So I went over to the design team, grabbed one of them and says, are you in charge of this cabling process? I go, yeah. So I walked over to the design team, and I had worked with on the design side a number of times and with different projects. And so I knew who to talk to and said, Dan, can you come with me for a few minutes? You got a couple minutes? I want to show you something. And we walked the 40 yards maybe in this building over to manufacturing and says, could you put this cable on, show us how it works? And he reached in there and set it in and goes, it's not hard. He says, let's power it up. And the cable wasn't attached. And you see the problem now? And we can't see it. There's no no clicks or no any. And he goes, oh, is that why we're having so many field problems? And the manufacturing folks are like, we've been telling you this for like 3 months. They didn't. Right. I said, this might be a great way to get credit by working with, Sarah over here to actually make a breakthrough and really improve your field performance. Oh, we can do that. Yeah. Oh, no. Why did you have to pay me to come all the way over here to tell you this in 5 minutes, kind of thing? Like, this doesn't make sense. But it has been a part of my consulting work is projects like that. In hindsight, it's frustrating because I shouldn't have to do that.
Right. I concur. And I've been in similar scenarios, even with just like peacekeeping between two warring tribes.
Yeah.
You get no skin in the game. But yeah, it's one quote saying, well, I'll tell you what it is, and you can tell me how we should characterize it. I know you've heard of it before, but it's one that says that 80% of all quality problems originate from design.
Oh, I go further. I think all problems in manufacturing come from design.
No, I've definitely seen manufacturing problems which are 100% rooted in manufacturing.
Yeah, I have to confess, I have a confirmation bias on my phrasing.
Right. So, and that's what you're talking about is a great example where you have an installation error because it's a cockamamie design. It just doesn't make any sense. Like a really simple one too is color coding wires.
Yeah.
Number of military vehicles where I see a rat's nest of cables and wires, and they're all white. All of them are white.
Yeah.
The designers
Not even
say,
camo.
right. Well, the designers are saying, I speak to the electrical engineer, said, well, on the side, it's written on the side. And you go, oh, this sort of tiny little line mark text, which is no more than 1 millimeter high, which rubs off within 5 minutes of this vehicle being used. You have to have a magnifying glass to see. You see where we're going with this? And some people see where I'm going with this and they just genuinely don't care. But just color coding wires.
We have to buy different colored wire now. You think of the cost impact, like, okay,
right.
Now it takes us 6 days to fix something that could have been done in 10 seconds.
But some are just, I've seen some vehicles where the wiring harnesses are unfixable. So they pull everything out because they can't, work out what's going on. And get a brand new power pack. I've seen that happen.
Yep.
It's bad, but it's a real thing. And you have people who have this sort of, like I said, that razor-like separation between design and manufacturer, or just design anything else, let's put it that way, because I suppose the whole color coding thing isn't a manufacturing problem. It's, what do you call it, a usability problem? It's a stupid problem. I know that.
Yeah.
But I mean, the JLTV, classic case, white cabling. That was a vehicle which in terms of reliability demonstration was about 3 times as reliable as it needed to be, and no other vehicle came close to actually passing meeting the requirements.
Mm-hmm.
And lo and behold, after a few years, the US Department of Defense has said, you know what, Oshkosh, we've had enough of your manufacturing nonsense. We're going to take your design and give it to another, I forget which company it is.
Another company that could actually make it.
Yeah, one of their competitors who lost the contract because their vehicle wasn't as reliable, amongst other things, as the Oshkosh JLTV. Yeah. And so Oshkosh have now designed a vehicle that one of their competitors who lost out to them is now manufacturing because they can't. I mean,
they couldn't do it themselves.
Crazy.
But I think design has something to offer manufacturing too. And when they talk, I think the Sarah going down and spending time and spending time with manufacturing and understanding the constraints and building that into the design, that's the sweet spot. That's what you want your organization to do. And there's all kinds of barriers, whether it's corporate culture or just mindset or whatever it is. You got to get over it. If you want to create something that works, you got to be able to make it and make more than one of them. And I got more stories on this, but I think we should wrap it up. If you've got more stories about interfaces between design and manufacturing and its impact on quality or reliability of your product, good or bad, if you got a Sarah, we'd love to hear about how well that worked and what kind of stories you got there. That'd be really cool. Let us know. Head over to accendoreliability.com/go/SOR. A couple of ways to get in touch with us there. And you can find Chris and I and the other hosts of the show on LinkedIn and our About pages. So plenty of ways for you to get in touch. And we look forward to hearing your ideas and comments and stuff like that. In this episode, like many of them, is kind of sparked by a conversation we had or an email we got or stuff like that. And so doesn't take much to get it started. And sometimes we can actually give you a pretty decent answer pretty quick. And so we try to help you out and inform others. So we that's kind of the gist of the show. So we look forward to your comments and questions. So thanks, Chris, for taking this one on. I know you had some interesting interfaces between manufacturing and design teams. So I knew it'd be fun.
Yeah, it's always happens though. Why does this happen? Oh, that keeps us in business, I suppose.
Yeah, there's that. But if it works well, we don't hear about those too much, but we buy their products.
That's right. And they don't tell us about it because they're too busy making money.
That's right. All right. Well, thanks, Chris. Talk to you soon.
All right, Fred, always a pleasure.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.